Again. It's like running a marathon today. But it's Haskell, so it's fun. Yeah, let's get this closed up. Yeah, so earlier today, this afternoon, I was working on adventure game and doing some refactoring. I promised some Rosby tonight. Some Rosby development seems like it should be pretty fun. Let's see. I don't know. I kind of want to work on this for a bit. Let's get some tunes. There we go. Yeah, been a day. Good day. Did a little skating. Took the kids to the park. It's fun. Yeah, time for some more hacking. Where were we with this? There was a bug. That's going to really annoy me. .exe, please. Yeah. Locked the front door, but we couldn't walk back. Oh, so annoying. Right. We're in 6. Which is right. That should be main hall. No room items, the exits. What's the freaking door right there? The freaking key and everything. Oh, I hate it. I hate it, I do. He hates it. I don't know. I might have to just let it go for now so we can focus on Rosby. Do this one later. Okay. Let's do that. Let's forget all about our troubles with that one for now. Yeah, sure. So where were we? Where did we leave off with Rosby? I think we were making some progress on our index, as I recall. I'll have to look that up. Yeah, let's see. Well, we had some stuff we haven't pushed up yet, so we're in the middle of something. Yeah. We have to do keep. That's this case here, where we just insert key and value. So let's do that. Get rid of that. Sorry, not core, the server. Store. V-tree. Okay. The more grunting and groaning as we twist our brains around and around, trying to implement this data structure. Okay, hopefully we got the split case right. And so we just have to do insert, I guess, here. Right. Oh, there was something else about the height as well that I was concerned about with the type here. Right, because when we split it, we wanted to make sure that the node we create, right, is one higher than the leaf nodes. Which is what our split continuation should do. Except it just constructs it doesn't check the height. Right, so we wanted to kind of say somewhere that when we call split on this node, here, that we're increasing the height. Or we should increase the height. When we call keep, it should stay the same height. So we're not changing it, we're not adding any new nodes. So yeah, let's do that. How can we do that? We could do that. We could do that, I could do that, I could do that, I could do that. I don't know. I don't have a good answer. What do we know though? What do we know? That's what we gotta ask. Right, we do know that this height is not the same, right, as the H that's given to the B-tree node in. We might be splitting this B-tree node. If we choose the split, we should get a node higher. I almost want this one to be like H prime or P. And we got to bring that type variable in scope. Now it's in scope, but what does it mean? Leaf node here. Right. So cannot deduce the type variable p bound by this pattern here is C. Okay. And split here. It binds our h here at the same height. So it's expecting these to be z's or zeros. Okay, I think I understand that part. What was our gadget encoding again? Matthew Brecknell, help us. Okay, so in this implementation for 2-3 trees, they kept the height variable same at this level. MJ with the keep push. Push. I guess the left, the right, the key constructs a new tree node with 2 children and 1 key. And it's the insert case for branches where we have kind of a slightly different pattern. Here, we have the node at some height p. Then we have keep TMA and push at TMA T. But where M is the successor to P, whatever P is. So in both cases, whether keep, push, when we insert into a branch on this, here we're increasing the height. So a T2. Yeah, this this goes a little hard to read. But we're just trying to understand the general idea here, the gist of it, and where these type parameters bind. Right, so we insert A or we insert C, depending on whether X is less than B or X is greater than B. So the ordering. Oh, this is the recursive recursion. and giving different continuations depending on the case. Ah, cool, cool, cool. Keep everything as it is. So we both call keep here. Keep, 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 keep. And keep. And the time it calls push is up here. I wonder if our push is right though. Or not our push, our split. Let me just double check that again. Yeah. N would be the height tracking type variable there. It is the same. We got it right on the leaf case. I don't know. Oh, we do, we do. Yeah, our node constructor. Construct a node. Lower children, upper children order. Yeah, okay. I think that will do it. We'll handle it. That's why. Okay, so what I think is going on here, as I understand it, is that when we insert in the leaf case, the reason why we don't have to specify exactly here, and only in the leaf case, that the split continuation increases the height, is because when we split a leaf and we call our continuation here, we create a node wrapped in our B tree. And our node smart constructor will construct internal node from our leaf children. And that node that it constructs is going to be successor H of the node we create. So if that's comes in as 0, in the case of when we call this split continuation, H will be fixed to our 0 constructor. And when we're fixed to 0, and then when we call the Gadget constructor to create the B tree node and wrap that in B tree, then we get the successor of 0, which is 1. So when we're splitting that first initial leaf, I think that's pretty much what's going on there, and that makes sense. So, oh hey Sandy, yo. I was working on the text adventure engine this afternoon. I promised people some Rosby, so I'm working on a bit of Rosby right now. So I was discussing discussing this a little bit with Simon, Cypher, and we were wondering, like, is the type level programming we're doing here really useful for the implementation of this, the correct implementation of this tree? Is it really paying off yet? That kind of thing. I don't think we're quite at the level of like dependent Haskell yet, but getting somewhere near that. But what do you think anyway? I don't know. Get some feedback here. Let's have a discussion. Cool. So when we insert into an internal node, then that's the only case we have left to do. This is the one where, because we're working with internal nodes and not leafs, that we have to have the relation on the continuation changed. Why am I writing a B tree? That's a good question. Maybe let's just reiterate and go over that again. Because I was also discussing this with some other folks, fine folks as well. Maybe this is a case of over-engineering, I don't know. Alright, so the general idea of our key value data store, we just have some small requirements. One, well, maybe not so small. One, we just want to make sure that the user can define the size of the data store. Okay, that's like our main thing that we're shooting for here. Am I drawing on my screen? Yes, I'm drawing on my screen. It's a Wacom tablet and a handy little program called Epic Pen. Alright, so our main requirement here is that the user can define the size of the data store. So for a key value database, memories, you can get a lot of memory these days. We're just doing an in-memory data store for now. But let's say they have 8 terabytes of RAM or something like that, right? Which is not crazy. And they allocate, so they want to allocate 4 terabytes to the data store. Right? The caveat being that as long as you give enough room for the runtime system to run with the program, which might be all the threading, client connections, parsing and handling of input and streaming it into the data store, let's say maybe a gig at most. We'll try and keep it under the RTS under that size. Can we do this? How can we do this? Right. User uploads. When you have 4 terabytes of room for your data store, a user can totally upload a 8 gigabyte movie or whatever, like their Blu-ray collection, you know, as values. It's just a really huge byte string to store. Do we want to store that in the RTS? I don't know. Because if we were just, because all we're trying to do is support get, put, and or get like update, put, delete. Keep thinking in HTTP. Keys. We're not really going for any kind of query or range stuff yet. So we could do this with just a hash map, right? This is like under the hood, some kind of tree, I think. Why am I writing a B tree? Partly to learn. Pretty much. I mean, there are B+ tree implementation libraries out there. Maybe we should use one of those. But I wanted to try it anyway. The idea was to write this tree out. I'm sorry that these are all da-da-da-das. It's a B+ tree, so all the data lives at the nodes. 0, 1, 2, 3, whatever. and they would contain pointers, values, but those values could be pointers to something else where we actually store those giant blobs of whatevers. So these might be a bunch of compact regions. We can call those blocks or whatever. It might be just some off-heap allocated memory in C, just so that the garbage collector is going to come in and visit all of these objects and go and do nothing with them because it doesn't really have to. So yeah, partly for learning. Just to learn how to build a B+ tree and an index and all that kind of stuff. So if you check on Hackage, there's some stuff there too. B+ tree, B tree. B tree. Yeah, I think this is the only one I've seen. Although look at this. It was B tree concurrent too. Yeah. Well, it's streaming, right? Like, I don't know. Maybe we should give up on writing our own for a little while, and just get this done. And maybe use one of these fancy libraries. Because the whole thing I'm doing on the stream, really, I just want to show people what it's like to program in Haskell. That it's not like, you know, only for super hard researchy problems, and, you know, only for research, only for academics. It's like, nah, man. Like, you can write databases in this stuff, you know. And I want to learn. I want to know how we can address managing large heaps of memory that we don't want the garbage collector to constantly touch, right? Okay, no worries. Nobody's gonna stop me. It's my stream. But thanks though. It's really nice. You know, and questions are good. I like questions. I like talking. So yeah. So like this one, like a backend agnostic concurrent B tree with relaxed balance. Ooh. Using a mix of I/O operations and pure STM. Neither production ready nor complete. Ugh. However, it's probably further along than ours, obviously. Caching. Yeah. So this one has persistence built in. Too much memory usage. Oh no. So like using a library like this, this would be a problem for our requirements. We haven't really gotten to parallelization or concurrency yet. Yeah. It, you know, it parallelizes, just not well. The other one, what other one we had? Haskell. So this actually provides two. First one is pure. Second one is impure. Backed by a page allocator. Yeah. This one uses some pretty schmancy types internally. Especially the impure one that's backed by the page allocator. Yeah, so they do it too. They track the height in the nodes. insert. I want to check. Let's check out their source, how they implemented insert. Do it in a monad. What's the type of tree? Ah, in a record. Don't got it. Product though. Oh, that's interesting, right? I haven't looked at finger trees. I've heard that name bandied around a lot. I have not looked into finger trees at all. What are finger trees? Let's look those up. Oh, there's a package for it. A general sequence representation with arbitrary annotations for use as a basic implementations of various collection types with examples, as described in this paper. Oh, Haskell, you're so funny. I love it. For a tuned sequence type, see this? So that's not a great place to find our answer. Yeah, it's what you get. Sandy says it's what you get if you generalize BST. It's a BST, binary something tree. It works over any monoid. Neat. Wikipedia. Okay, this is real talk, right? It's good. Prove the functional data structure. Pop. So the other approach anyway we could take with this project is that we could just try and use one of these libraries, you know. That's how libraries improve in the ecosystem. All right, you need users. We could just take like Haskell or this B-tree concurrent, implement our key value store in it. We might have to wrap it a little bit to get that size invariant we want to be able to maintain as part of our structure, in the store part at least. We could do that, and then yeah, we could make this more parallel or better parallel maybe as a thing. And then a lot of the hard work's already done for me because it's been interesting. But yeah, I don't know. Now I got to think about this, Sandy. Yeah, I don't know. I've been having a lot more fun doing the adventure game engine, to be honest. I'm liking the Rosby stuff, and I'm doing it because it's hard. But yeah, getting stuck on the best way to encode this tree and trying to build it up is sapping me. But we make small progress, which keeps me going, and people like it, so I keep going. I'm like, okay, to get through this. So that's something to think about anyway, Sandy. It's a good point, right? Like, we want to finish this in a reasonable amount of time. There's already implementations out there. Why not help the community and use them, right, instead of writing our own? Yeah, well, it's been worth it learning too. So that's good too. Okay. Right. Okay, so inserting the branch node now. This is where we're we have a little bit of a different requirement than inserting on the leaf node. Right. Oh, that's good. I don't know. Anyway. Split A, split A, user node. Okay. You know what? Let's leave it. I'm gonna switch. I don't have the brain space for us right now, and Sandy, you've given me a lot to think about. Let's go to the adventure engine. Fix that bug, because I want to fix the bug there. Okay. Shut it down for now, Rosby. Sorry, folks. Rosby's gonna go on the back burner for another week. Until I figure out what I want to do with it. Alright. Adventure engine. This one makes me happy. I don't know. I've been like hacking on this in the afternoons. No, you're not a toad, man. You're the best, Sandy. I like having you around. Alright, I like your book too. Algebra driven. It's super good. Type driven design's a great book too, so. And it's great to see you hacking out there too, following your streams and stuff and working on that. It's great to see you come alive. That's something I've been thinking about streaming too. Is I don't have it with me, but I have a remarkable tablet, and I got Hello World going on it, like I was saying. And it would be super dope to maybe like show that hacking on the stream as well. Let's have ideas for computers that are not glowy screens and keyboards. And programming that isn't stuck like this all the time. Sandy's making it happen. He's doing the part. He's doing a lot of work on that. So you should check out Sandy's stream, Isovectors. Doing good work, friend. Doing good work. Ah, it is. You know, and I like seeing the feedback come in and, you know, improving the that heuristic. And some of the code is coming out of it. It's just nice. You know, be really cool. We get it gets to a point someday where we can hook it up with the editor on the tablet. We get, you know, intents built in and all kinds of stuff, so you can just draw it in. You can just program by drawing and filling in the holes and answering questions the computer has for you. It's gonna be good. Yeah. All right, so the bug I'm tackling right now that we did earlier, we created this earlier today, so it's something silly I've done. So we're refactoring the commands. We're doing, instead of parsing everything into like, and all the commands in a giant sum type, we're going to implement like a dynamic dispatch. So we're pushing some of the parsing complexity down to the command handlers for parsing the arguments to a verb. For the trade-off, there are those that we can dynamically introduce new commands to the game, tighten our code up a little bit, and make things just a little bit easier to extend as we go forward and expand the universe of verbs that we handle. And I'm right in the middle of migrating all the commands. I'm in the middle of migrating walk. It's not done yet. It's still to do. The problem is that I introduced a bug when I migrated it. I messed something up. Right? So right now you can walk to the front door. Right? This works because in the game map and the game data, the mapping for the different exits in this room are keyed by right now, the lowercase name of the room, or the exit. front door here. And it gives back an exit ID, which you look up in the database of exits to get the actual exit and the destination it attaches to. And then you set the user's position to the new one and all that sort of stuff, right? So when I do that, it does a lookup here for the exit ID, changes the state to the to address. Okay. It's the world exits list here, right? Entity ID 3, exit name front door. It goes from 0 to 6, right? And we set player inventory, the player room to entity ID 6 now. That's the destination of the exit when we did that walk. Now, right, I'm in the main hall. I should be able to walk to door because in the room known by the ID 6, the exits are keyed by door and entity ID 5. We go to world exits here. Entity ID 5 should be in here. Yeah. Its exit name is door. Yada, yada, yada. From 6 to 0. Okay. But when I run it, I get my exit does not exist error, which is hella not good and super annoying. You know, so I went out, I skated for a little bit, hung out with the kids, we played, landed some ollies. You know, I'm getting a little better at that. Sometimes you just need to take a little walk, come back to the code, and it'll just come to you. You'll fix it, and it'll be great. Let's see if I can do it here today on the stream. Ow. Right. So this is now what commands look like. Instead of parsing all of our a command is no longer a giant sum type. It encapsulates its verb, and we look up the available commands in the state of the game engine, right? Which we have embodied by get command here and parse this stuff. Super good, right? We split this into, by the way, just as a kind of recap, we split this into our REPL as a nice kind of split point for this refactor, right? We decided like, okay, this is a good insertion point for our code now that we know that it's like good. So we now have handle prime in here and all the other code that we were using before to handle the input, parse it, and update the world and stuff like that is out. Still here, we haven't deleted it yet, but it's because we still need bits of it. But frig, man. Something about my hasty copy pasta has made this look up here not work anymore with exit name. Right. So I normalize this args. So the args is a list of text. Function takes a world list of text, yeah, and we map text.toLower on it so that it normalizes everything, because we're going to make sure that when we construct, like we get the world data and deserialize it, those keys are going to be lowercased for the room names, so that when you type in that exit, type whatever case you want, right? Pretty straightforward. So that should be the right equation for that. And then unwords takes a list of texts and mashes them all together into one text with spaces between them. And we debug traced it too. So that when we do this lookup with exit name here, it's freaking door. It's door. Oh wait, no, here. Ooh. We also get exits does not exist here as well. I wonder if we change this to Space Wizard, if we'll see which one it is. Sorry. Maybe I'm looking at the wrong term. Yeah, I know. Yeah. Maybe that's what it is. Ah. See? Sometimes you just gotta go skate, friend. Go for a walk. Okie dokie. Built, yes, good. Let's try it. Okay, front door, right? That's good. Back to door. No, still get exit does not exist. Okay. That means this. Yeah, this should be right. What the F? Let me jump to the REPL. Just make sure. Yeah, we go into handle. All right, good night, Sandy. Thanks for popping by. It's nice to see you again. You too. Yeah, okay. Output the rendered world. Rendered as world prime. Yeah, rendered of world prime. Yeah, so this should be the world returned by handle. So what we're seeing in the output is the next state. Which we're in the main hall, which is right. Like, am I just not seeing something correctly? Entity ID 6, room names, main hall, description, blah, 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 items, exits. Door. Entity ID 5. Yeah. What the heck? Maybe we should output the world in the error case. As well. Okay, so we walk to the front door. That works. Okay, our current state is okay. We're still in 6. And the room list has changed, obviously. Like, the room exits list hasn't changed. No, of course it hasn't. If I type the full verb out. No. Recognize command. Yeah, that's expected. I still will walk. That's not an error? That's fishy. That's a little fishy. What's happening there? If I type walk front door, I don't get an error, but I end up here. Why is that? The playroom is 6. Okay. When I look up the room from that, in the rooms list, world rooms list, from that 6. Right, I should be getting main hall, which is what's getting rendered to items room exits. But if I just try to type door, it doesn't get it. Why? Walk 2. Okay, let's go back to that handler. So look up the player room of... I don't really need that. And the world rooms. I'm gonna need my good old friend debug trace again because just not seeing it. This time, when we look up the exit ID in the current room, let's trace out the show for that room. Okay, so we lock the front door. We change state, we're good. Okay, I get the exit does not exist error. It's pulling the front porch. Okay, that's a problem. Orbiting it, narrowing it down a bit. So for some reason it's pulling the front porch. Pulling the front porch. wonder. I'm going to jump over the REPL. So we get either the game error from handle or the next world, which we try to render. We loop with world prime. The loop takes a world, so that should be feeding the new state of the world back into our loop. G and W. That's what's happening. Haha. Subtle bug. This W is taking from this one up here in the outer scope. Just the initial world. We should be using this world, or more closely bound one, so that's there. That's an interesting, not so interesting one, but one to look out for, I guess, when you're reviewing Haskell code. It might be a bit of a code smell. Be sure that you're supposed to be, you're using the most closely bound thing, right? I need to use world. I wasn't using it here, but I don't think I was getting an error because in this case, we're using it down here, but handle needed to be using it. Okay. That's why. So we should walk the front door now. Get to the main hall. We should be able to get back to the front. Yeah, okay. There we go. That's better. Phew. Man. That's a tricky, pernicious little error there. Oops. Okay, let's get rid of all that debug stuff. Bye-bye, Trace. Thanks for the help, friend. It was the state. Something about the state wasn't right. But we got it. We got it. Let's jump over the REPL and get all that other stuff we were showing that's unnecessary now. Much better. Okay, cool. That's a nice little error there too. Okay, now we can mark off walk is done. Migrated. Now let's go over. Drop. Like the bass. It'd be great if the timing worked out on that, but it didn't. Ugh. Okay. Let's port drop. So. let's checkpoint that here. We created a dynamic dispatch framework for handling commands. And migrated walk. Okay. Let's migrate over pickup next. Okay. Oh, sorry, those will have to be changed. Handle look. Handle drop. Yeah. Okay, pickup. So we basically just need the pickup code. What does it take as input? The item name, the item ID. So we'll get the item ID name from the arguments parameter. We'll have to look up the item ID ourselves, like we do in the parser in this case. But the rest of this code should be okay. To borrow, put in our handler. Got a double where there. Oh. Okay, so we just need to bring an item name into scope. From args. So if we handle pickup, it doesn't matter what the world is, but if we have an empty list, that's another error again. What do we call that one in the game terms? Unrecognized, missing parameter. Cool. And in the other case where we have args, again, this only really accepts one word. Somebody might try to type the. We might want to like peek at that and make sure we drop it, not just do the rest, but that is a to-do item for now. Let's just make sure we get the item name and get everything back to where we were. And we're going to need that map t.lower as well. Over args. Then we need the player room, which is the world, player room of the world. We need the rooms database, which is the world rooms map. Oops. We need the items database. Cool. And then we got to add lookup the item ID here. We had that code down here. And we need to basically just add that back in. Oh. Of course, we also got to get the room. And that's over here. Okay. Of course, we have to convert unknown input to or just replace it with a game error instead of an input error. Yeah, feels like we're kind of now smushing together the error sum type that's going to turn into a giant. Space Wizard. Space Wizard is basically my error for like this shouldn't be possible. Item ID. So that would be kind of like what we're looking at by item name. Now if this fails, this would be not a missing parameter, but unrecognized. Item not in room. Yeah. We'll just make that text. Should be item not in room and item name. Okay, and then player inventory. That is player inventory world. And then remove item. We have to pass in the item name, so let's do it this way. So that we can go here. No picking. And we'll pick up, come on. There we go. Alright, pick up the purse. Ooh. We didn't add the command to our thing, so it's not recognizing it. That makes sense. So let's just go add pickup prime to game state. That's not what I called it. Yeah, that's better. Cool. So just like before. Cool. Okay, that's pickup done. Let's get drop. Anyway. Okay, drop. And immediately right off the bat, there's a missing parameter error. Otherwise, and we'll grab our drop code. Same as handed out there. And just like before, we're gonna have to just add item in here, item name. Just to have it bound. Okay. That's just not properly indented. Okay, there we go. Item name. And then we have to get the item ID. Okay, no problem. Item name. That's going to be defined again. So I feel like that's going to be a helper a good helper function. Args. And then we got to get the item ID, which we have from down here. And then it's no longer item is not an inventory. I'm not an inventory. Again. Oh, I used a type alias for that. Cool. Yeah. Oh, I need the item D as well. Okay, no problem. Why does it think that's duplication? Player room, player inventory, world rooms. That's weird. I'm confusing the heck out of the linter. That's okay. We're going to be deleting that code later anyway. Okay, so let's drop. It looks like it compiled, so let's give it a shot. Pick up the purse. I drop the purse. Oh, right. We didn't add the command to the initial list, so let's just go add that. Pick up the purse. I dropped the purse. Ugh, I messed that up. I know what I did wrong. I probably defined drop with the wrong verb. Yeah. I'm careful of that. Pick up the shovel. I drop the shovel. Pick up the purse. I walk through the front door. I drop the purse. I walk through the door. I pick up the shovel. I walk through the front door again. Thanks, Checksor, for stopping by. See you later. And I drop the shovel. And I walk through the door. And I sit on the front porch, smug with satisfaction that I have done a good day's work. And I quit. All right. This is going well. Okay. Look is going to be a lot like our foo command, I think. Oh, what did I do? Except it's just going to do nothing. It's just going to re-render the world. That's all it's going to do. So we're lucky that pickup actually worked since we named all these. Oh, we didn't add all the verbs into the list, so that makes sense. Yeah, never mind. Look prime. So that needs to be a set of verbs, so we don't have the accidental case of introducing an error where we have a command with dual verbs, like identically named verbs. But we don't have an equal instance, so I don't know if we can build a set necessarily. We might need some kind of interface for working with the game state to make sure that that invariant holds in our program. However, let's continue on to look. Look doesn't really do anything. Other than just returning the world that it got, so that one's super easy because the game loop will re-render then. Yep. Cool. That's look done. Okay, just examine left. All right. So we had two cases actually. We had two functions. We had examine in room and examine in inventory now. I think we could probably reuse these. Right, they both return either game errors. They both take an item name and item ID, entity ID item. But now, instead of the part, we'll just kind of do what the parser does. Figure out which one they mean and dispatch to the right function. So that's cool. We'll move those up. Closer to where we're doing examine. Okie dokie. No matter what we get, if we don't have any arguments, well, of course we get the error. Missing parameter. But otherwise, we get some world and args, so we have to do something with those. Now, we made the distinction when we were doing examine to match on the preposition. So if the first word in args is my, the preposition my, that means they want to look in the player's inventory. It also means we can't have an item in the room with the key my as well. Or if we have the first word, it is my, and there are more words, then we can do the inventory look, and that's unambiguous. All right, and then we could have a room in the word named my if we wanted to for reasons, even though that might cause weird things perhaps later on, who knows. But maybe not. My would still be okay. Drop my. Yeah, anyway, I don't think that's too ambiguous, so famous last words, I know. So let's just pull those apart. W and W's, word and words. And then the case match on W. It's the preposition my, then we do that. Otherwise, we examine in the room. We need, in order to do examine in inventory, we need the item name. Item name be equal to, ooh, that's going to be contextual dependent, so that's going to be the W's concatenated together, as long as it's not empty. So I wonder if we should match on them together as well. Give mine the empty list. Does that seem right? I don't know. Because that would just go to the otherwise case where we're trying to do examine in room. The only case that we really care about here is that W's isn't empty. Right, so how would we say that? It has at least one element. We don't care what it is. Can we do that, maybe? It's kind of a weird way of putting it, but it's not. Let's see. Let's see if that works out. Maybe there's a better way of explaining it, of putting it together, but yeah, I don't know. Unpack, right? That's going to be a map. And that's just going to take the rest of... Oops, all right. In. Okay, so now we have the item name. We also need the entity ID of the item, which means we need all the other stuff as well. Ooh. Right. Rooms. World rooms. Yeah, of the world. And we're going to need items. Player inventory, that's already taken care of in that stuff. I think we just need items right for now. An item, do that lookup. That one. In the player inventory. Hello. Okay, now we can do examine in inventory. We give it the world. We give it the item name. We give it the item ID. Why do you hate me? Oh, not t.unpack, t.pack. Two lower. I don't have the item name yet. Right. Fair enough. Fair enough. To make this a do block. And this is no longer... Okay, it's going to be a game error. That's an unknown parameter. Unknown... Was a missing parameter? Unknown parameter. Item not in inventory. Probably prime. Yeah. Okay, not so bad. One hole left. I feel like we're going to do something the same, except... Yeah, this is kind of nasty code here. Look at all this duplication. That's okay. We'll figure it out in a minute. I guess we didn't really need that. Okay. Not exactly as small as I thought it would be, but... Examine that purse in the room. Yeah, we didn't add the thing again, because I'm dumb. I keep forgetting. It's okay, though. We're almost there, friends. We'll just make sure that examine is examine verb. Yep, good. Okay. Examine that purse. Okay, well, we got a bug. Let's pick up the purse. Examine my purse. That should... Yeah, weathered old leather purse. Okay, so it's examined in room. That's... We might have made a mistake on. Yeah. And examine. Yeah. Examine in room here. It's getting the empty string because we actually want this cat up here. Examine the purse. It's not in our inventory. Oh, it's going into... Hang on. Hang on. Ren, what is going on here? That ain't right. Uh-oh. How's that? How are we even getting to that? I'm not in room. Oh, we're doing it down here. Right. Okay, we're still not quite getting it right. I thought it would be args for the item name. Handle examine. It's not my. Debug.trace. Doing something silly. Almost there. Okay. So I'd expect that from here. Just this one. Why is that? Can I just replace it with a space wizard to make sure I'm getting to the right branch? I mean, it's tracing out, so I'd imagine we are. Yeah. Okay, what the heck am I doing here? Player inventory, that's why. This should be in the items. We did need items. But that's not by item name, is it? It's by item ID. Right. So we had to do this in that case. Yeah. And this one must be the does not exist. No, item not in room. Yeah, that should be better. I don't want to build. Pop up. It's already built. There we go. Okay, examine the purse now. There we go. We can pick up the shovel. Examine my shovel. We're holding the shovel. We examined it in our inventory. Just try to do examine shovel. It's not in the room. Okay, that completes examine. Okay, this has been an extended feature. An extended stream, because I streamed quite a bit of this afternoon. So I'm not really sure what I'm going to name the stream when I upload it to YouTube. If it's going to be Rosby or if it's going to be Adventure Engine. So we kind of touched a little bit of both here, but figure that out later. Okay, so the final step now in our refactor. We've got all of our code over to the new stuff. Right, which means we have a bunch of code now that is dead. No longer being used. We just have to get rid of all that. Right, so we just start deleting stuff. Definitions we think we don't need anymore, and see what happens. So the first thing I'll get rid of is command, I guess. Let's checkpoint that here, actually. Modify. Rated rest of the commands. Dispatch. Something like that. Okay. So yeah, let's go be ruthless. Where's our command type? Let's get rid of that. Fuck up. Where did it go? Update, examine. Ah. There you are. Boop. All right. We're now going to get a lot of type errors. And we just delete anything that has a type error referencing that data structure. This, gone. Next, this one, gone. That, gone. Okay, compiles. Next. What else can we can get rid of input? And get rid of input error. All right, follow those type errors. Gone. 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 Get rid of prepositions. Get rid of that. Get rid of that. Ah, merciless, merciless. Yeah. Gone. See you later. It's nice knowing you. This one we still need. Actually, we might need parse as well. Hang on a second. Low down. Because we did wrap those types. So, yeah, there's still this, but can we fix that? That's wrong. We got rid of hand food too. Let's make that game error. So it's not empty input we want anymore for that. There's our gamer. Missing command. Unrecognized command. Okay. Right. So that would be missing command. An invalid verb. Unrecognized command. Okay, type error is gone. Don't think we actually ended up using invocation here. Okay, we're good again. Get rid of that. There. Get rid of that. Just while we're here, deleting stuff. Look at that copy pasta getting all over the place, right? Okay, cool. We can rename this command prime to just command. Let's replace. Oh. I missed a spot. And what else? That's it. Let's check that in. Oh, look at this. We got some imports we don't need anymore. Cool. Let's check again. Okay, deleted all the old refactor. Alright, there we go. We completed a pretty major refactor in Haskell. Right, we wanted to replace how we parsed and handled commands with a new system. And we did. Right. So what do we get now? Well, let's just review what we have here. We can diff this against master. All right, we updated the REPL. We added the idea of game state, so we're going to start splitting things out from world probably in future refactors into the game state. It's going to track sort of more meta things about the game, like what commands are available. We might even put stuff like our scoring and the number of turns a user used if we want to make something like that, kind of like Zork. We removed command as a sum type and made it a product. By doing so, it owns the verb, and the game state tells us which commands are available in the list. So that kind of gives us a bit of a dynamic lookup. and we dispatch to the command's function, which is also contained within the command. So we can dispatch our input to that, our parsed input. So that kind of like compressed together parsing input and handling it. Once we started implementing all those commands and migrating all our separated code before. And the reason why I wanted to do that was because I found in the last while ago when we were working on this, in adding a new command meant we had to go and make sure we update a bunch of different places throughout the code base. Whereas this now, you know, you implement the command in one place and that's it. And then you can add it to the game state, and we get the added flexibility of being able to add and remove commands. So in the future, maybe we do like the pickup action, maybe we can attach new commands to items, and then the item can now add the command to our list of commands in the game state. So that'll be a cool little innovation we get out of this. Yeah. Overall, sorry, I wanted to check also, we added 344 lines, we deleted something around the same. So we probably broke about even with this refactor. I was hoping actually it would make the code a little bit smaller. Let's push it up and make a pull request, and I don't really have to make a pull request. I could just merge into masters, but whatever. Just push it. Okay, and then we'll probably call it a night after that. Oh, I haven't signed in a while. Huh. Oh, I was going to ask me my 2FA, and that's my phone, which is also my camera. Okay. So, anyways, the code's up there. And that's that. Sweet. I think that's great. Well, this has been a Haskell refactor. And I hope you enjoyed. May your monads always be free. May your types always check. And I'll see you again next week. Peace.